Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what was covered in week 4. So we started our journey through sequences and series. So a sequence is just a list of numbers following a pattern. For example, this here is the sequence of square numbers. So these 3 dots at the end mean that the sequence goes on forever. So this second sequence is one where we start at 5 and each successive number is multiplied by 5. And this third sequence, we start at 5, but we're adding 7 each time. So in each of these sequences, each of these individual numbers is called a term. So I've written out the first 4 terms of each of these sequences. Now we're going to be especially interested in 2 types of sequences. We're going to look at geometric sequences next week. So this is a geometric sequence. But in week 4, we looked at these kind of sequences called arithmetic sequences. So what makes a sequence arithmetic is if you're going up or down by the same number each time. So this sequence is arithmetic because we're going up by 7 each time. These 2 sequences are not arithmetic because we're not going up by the same amount each time. So this formula here is what we call the recursive definition of an arithmetic sequence. Tn means term n. So what this is saying is, to get the next term in the sequence, you take the previous term and you add some constant d. D is called the common difference. So this means you're adding the same number each time to get the next term. That's what makes a sequence arithmetic. So another way to look at an arithmetic sequence is through this, which is called the recursive definition for an arithmetic sequence. So Tn means term n, so T1 is term 1, T2 is term 2, and so on. Tn plus 1 means the next term. This says to get the next term in the sequence, you take the previous term and you add some constant d, which is the common difference. So for this sequence up here that we already decided was arithmetic, to get the next term, you take the current term and you add 7. So here the common difference is 7 because we're going up by 7 each time. Now we can use this formula here to calculate the value of any term. So let's say I wanted to find the 40th term. So we denote that T40. So rather than just keep adding 7, which would take forever, using this formula, A is the first term, D is the common difference, N is the number of the term you want. So T40 is first term, plus n is 40, n minus 1 is 39, times the common difference. So that equals 278. That would be the value of the 40th term. So let's look at using this formula for some harder questions. So here we have the 12th term of an AP, which means arithmetic progression, just another way to say arithmetic sequence. The 12th term is 32, 20th term is negative 24. What is the third term? So if I want to find the third term, using the formula Tn equals A plus n minus 1d, I know what n is. For the third term, n is just 3. So the third term of any AP is A plus 2d. So to find T3, I need to know A and I need to know D. So straight away, when you're finding 2 unknown quantities at the same time, you should think simultaneous equations. So if the 12th term is 32, that means T12 is equal to 32. So T12 is A plus 11D, A plus n minus 1D. We're told that that equals 32. And similarly, T20 is going to be A plus 19D, and we're told that that equals negative 24. So to solve these simultaneously, we're going to subtract. If I subtract, the A's cancel out. So 11 minus 19 gives me negative 8D. 32 subtract negative 24 gives me positive 56. So here, D is minus 7. So what we'll do is we'll substitute in this into this equation to find A. So A plus 11 times D, which is negative 77, equals 32. So A would be 109. So once we know A and D, we can write out the sequence. This will be the sequence 109, D being negative 7 means it goes down by 7 each time. So this will be the sequence 109, 102, 95, 88, and it goes on forever. So clearly, the third term is 95. All right, let's try this one here. So we've got 3 terms that form an arithmetic sequence. We want to find k. So if a sequence is arithmetic, it has a common difference. It's going up by the same amount each time. So to find out that common difference, you take any term and you subtract the term before. So third term minus second term gives the common difference, as does the second term minus the first term. So solving this equation, we're going to make one side equal 0. So I'm going to add k squared to both sides and then subtract 7. So when we've got here to a quadratic, you can use the polynomial solver on your calculator, or you can factorize. So 2 numbers that multiply to negative 6 and add to 1 are positive 3 and negative 2. So we get here that k is either equal to negative 3 or positive 2. So just so you know, if k was equal to negative 3, this would be the sequence 9, 7, 5. If k was equal to 2, it'd be the sequence 4, 7, 10. All right, let's now look at arithmetic series. So when we talk about a series, it's just the sum of the first n terms of a sequence. So for the sum of an arithmetic sequence, called an arithmetic series, we use this formula here. So we're calculating the sum of the first n terms. So if we have this arithmetic sequence here, so if we want to calculate S30, that is the sum of the first 30 terms of this sequence. So it's just n over 2 times 2a, 2 times the first term, plus n minus 1 times d. And of course, d here is 7, as we saw before. And so we get 3,195. That's all there is to it. So now we're going to look at an example where we're using this formula to solve for n. So how many terms of this sequence are needed? So the sum is 2,448. So because we're talking about the sum, i.e. an arithmetic series, we should use the formula Sn equals n over 2, 2a plus n minus 1d. So all I'm going to do in this formula is substitute everything I know and rearrange to find n. So we know that a here, the first term, is 10. We know here that d is 8 because we're going up by 8 each time. And the question tells us that the sum of the terms is 2448. So now we're going to solve this equation here for n. So what I'm going to do is make these brackets a little easier to work with. So all I did was expand the brackets, 8 times n, 8 times negative 1. So of course 20 minus 8 equals 12. So now I'm going to times by 2 just to make this equation even easier to work with. So I get 4896, and I just get n times 12 plus 8n. So now what I'm going to do is expand the brackets, n times 12, n times 8n. So you can see here that we have a quadratic equation, so I need to make one side equal to 0. So to solve this, we would either use the quadratic formula or your polynomial solver. It doesn't matter which one. So we get 2 solutions. We get n equals 24, and there's also the solution minus 51 on 2, or minus 25.5. Now, obviously, we can't have n being a negative. It's the number of terms. So we conclude here that n is 24. 24 terms of this sequence need to be added together to get a sum of 2,448. So note, when we're solving an equation like this, we need to get a whole number for n, because you can't have, the 3.5 term. That doesn't make any sense. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.